Yes, everybody, welcome back to school after our 2-week break, and back to the video notes that we'll be taking once or twice a week for the rest of the year. And we're going to talk about what's called percent of change today, and this is what you're going to need for your notes on Monday. So let's get right into it. Get out your notes page. Again, percent of change is what we're doing. So when we talk about a percent of change, if you look at the TEAC that's written for this is what we go by. It says that we're estimating and finding solutions to application problems involving percents and other proportional relationships such as similarity and rates, which is what we've really been doing for not only the week before we left for break, but this last week that we just had with all the percent stuff we were doing. When we talk about vocabulary, let's look down at our vocabulary box. Percent of change. It's a ratio that compares the change in a quantity to the original amount. Something like if something cost $50 and then it was on sale for $40, what was the discount? What was the percent off? So something like that would be an example. Okay, so if a percent off you would find if you didn't know it, would be an example of that. And the next two examples, the vocabulary should make sense. Percent of increase is just when something gets increased, and a percent of decrease is a percent of change when the amount is decreased, and that should be pretty simple. Maybe these words you just need to take a quick look at. Increase means to get bigger, decrease means to get smaller. Okay, so let's get into some examples and just a little bit of talking about this. Notes. One way to describe a change in quantities is to use percent of change, and there's a proportion that's right here that we're going to use to find percent of change. And all it is this looks just like the percent proportion we've been doing. The difference is the percent. The original is 100. Okay, or since we're doing the difference, the amount of change. Okay, same thing. The amount it changed is the same thing as the difference, and the original amount is right here. And it'll make more sense the more we do these, what we're actually doing to solve these. So, it says in this question, we'll get to the question in a minute actually. This is pretty basic again. If it goes up, it's an increase. If it goes down, it's a decrease. Pretty simple. Okay, example 1. Eduardo measured a tree after it grew for 1 year, and it was 4 feet tall. After 10 years, it was 10 feet tall. Find the percent of increase. Okay, first we have to actually find how much the tree grew. Well, the tree was 4 feet tall. After 10 years, it was 10 feet tall. So the amount that it went up was 6. It went up 6 feet taller. So that is the difference, or the change. And the original is what it started at. Well, it started at 4 feet. And then we're just going to do our basic proportion. We're trying to find out the percent it went up. We're going to have our x here for the percent. So we cross multiply, we would get 4 times x is 4x. 6 times 100 is 600. And then when we divided this, we would divide 600 by 4. And I'm going to quickly do that to get our answer. When we get that answer, that is the percentage. Now, this might look a little weird that it says that the percent is 150, but if something doubles, it's gone up 100%, right? If the tree went from 4 feet to 8 feet, well, it increased exactly what it was before, so it went up 100%. So in this example, it actually went up 6 feet, which was taller than it started, so that's why the percent is higher than 100. So the percent we found, 150. Okay, let's look at the next one. On the first week of school, 50 students in school did not turn in their homework. On the second week of school, only 30 students in the school did not turn in their homework. Find the percent of decrease. So again, we're going to set up our proportion. We got 100. It says find the percent, so that's going to go here. That's what we're trying to solve. And one thing we have to do is we have to find the difference. We have to find what it changed. So it went from 50 to 30. So the change was 20. It went, even though it went down, that'll just determine what we say at the end, but the change was 20 students. The original or starting amount was the 50, so that goes there. And this is a pretty easy problem where you probably would not have to even do the cross multiplying, because you probably know 50 times 2 is 100, so 20 times 2 is 40. And again, the only difference is the way you're going to say this. You're going to say there was a 40% decrease in the amount of students that did not turn in their homework. Okay, so you hear how that sounds, where you just say it a little differently. Even though we found the difference doesn't always mean it's a negative or positive. You have to sometimes imagine it as an increase or a decrease in this particular problem. Okay? Next, example 3. It's a you try. Oh, there it is. So, really quick, pause the video and take a few minutes to do the problem, and then come back and get started again. Okay, you should be back by now. Let's do the problem. Jake had $600 in his checking account. Jake's lucky. He now has $654. Is this an example of a percent of increase or decrease? And this just shows you how simple that question is. It's obviously went up, so it's an increase. And now we're going to find the percent of change. Again, percent of change is the amount that it changed by. So it went from 600 to 654. So us quickly doing this, even if we need to, tells us that the change was $54. So that's the top number. The bottom number is the starting amount. Well, the starting amount, it said, was 600. So that's this. Okay, we can set this up, the rest of it as a proportion, since we're finding the percent. That's why the X is there. Now, simplifying this side first would probably help us. In fact, if I divided both of these by 6, I'd get 9 over 100, and look at that. That would mean that is the answer. So, that means his checking account had a 9% increase in it. Alright? Number 4, example 4. Kenya spent 60 minutes reading yesterday. Today she spent 45 minutes reading. What is the percent of change? Okay, so again, we set this up. We're trying to find the actual percent, so the X is going to go there. She spent 60 minutes at the beginning. If you want to write that down first, that's fine. That's the original starting amount. And the top number we have to find is the difference, or the change. So she went from 60 minutes to 45 minutes, so that went down 15 minutes. Now, if you know time well, you might be able to reduce this pretty easily. I'm going to cross multiply and solve just to give you some practice doing that. So 60 times x is 60x, 15 times 100 is 1500. If I come over here and I actually do 1500 divided by 60, again, my 2 would go above the 0 because I'm dividing into 150. Can't divide 60 into 30, bring down my 0, and now I've got 60 into 300 is 5 times, and again, our answer is the percent. So 25% was the percent of change. And again, if you reduce this one over here, you'd have gotten 1/4, which we should know is 25%. Alright, another example. Example 5. 3 months ago, Maya could walk 2 miles in 40 minutes. Today, he can walk 2 miles in 25 minutes. What is the percent of change? Now, the miles doesn't matter. That's the same both times. So we write our proportion here. Again, x over 100. We're looking for the percent, so that goes there. The starting amount, we write that down right there. That's always going to be in the bottom. The original time they gave us was 40 minutes. The next thing we're going to write down is the difference. So he went down from 40 to 25, so that's a 15-minute change. We're trying to find the percent that he increased his time by. Basically, it says percent of change, but they could say what was the percent he changed his time by. So that's what we're doing. So I would probably reduce this first, just as a good thing to do, but we can do our cross multiplying also so that we see how that gets done. Okay, 40x equals 1500. X is what answer I get when I divide 1500 by 40. I could quickly do that, and then maybe come over here and do 4 divided into 150, which is probably going to have a decimal. Yes, it is. And if you need to stop the video at this point just to catch up, then that's fine. So again, when we get our answer, that is the percent, since that's what we were looking for. So Maya's time increased by 37.5%. Okay. All right, let's look at just a couple quick models. It says use the model above. The model above shows a 50% increase. So whatever they're talking about, this is 100% of it, and then it got 50% bigger, whether that was something about money or some kind of food amount or weight or something like that. So it says use the model below to show a 25% increase. So we want to go about halfway between this, and that's 25% extra, and that's what that would look like. Okay, last one, tax example. This is what you need to do before you come to class, okay? You're going to figure out which has the greatest percent of change. So you got to do all 4 of those. So make sure you get that done. And again, now that we're back at school after the break, we got about 50 days to the STAR test. But again, we all want to wish you this, and hopefully you're ready to get ready for that STAR test in about 50 days. We got to work hard in all classes, especially math. Of course, I'm going to say that, but work hard in all your classes getting ready for the STAR test, okay? All right, we'll see y'all. Have a good day.